We begin with a surd that looks simple at first glance, but hides a clever trick inside. The expression is the square root of 81 divided by 9 minus root 80. Our goal is not just to simplify it, but to make the denominator clean and free of irrational terms. First, notice the number under the square root in the denominator. 80 can be rewritten as 16 times 5, and this is useful because 16 is a perfect square. Taking the square root of 16 times 5 gives us 4 root 5, so the denominator becomes 9 minus 4 root 5. At this stage, we face a classic situation, a binomial with a square root in the denominator. To remove it, we multiply the numerator and denominator by the conjugate, which is 9 plus 4 root 5. This step does not change the value of the expression, it only changes its form. Now multiply the denominator using the identity a minus b times a plus b equals a squared minus b squared. This gives 9 squared minus 4 root 5 squared. Simplifying further, 9 squared is 81, and 4 root 5 squared becomes 16 times 5, which is 80. The denominator is now 81 minus 80, which equals 1. This is the turning point of the problem. With the denominator reduced to 1, the entire expression becomes the square root of 81 times the quantity 9 plus 4 root 5. Since 81 is 9 squared, its square root is simply 9. We are left with 9 times the square root of 9 plus 4 root 5. Now observe something elegant. The expression inside the square root can be rewritten as a perfect square. 9 plus 4 root 5 can be rearranged as 5 plus 4 plus 4 root 5, which matches the identity a squared plus 2ab plus b squared. This means the expression is the square of root 5 plus 2. Taking the square root removes the square, leaving root 5 plus 2. Finally, multiplying by 9 gives the simplified result, 18 plus 9 root 5. And just like that, a complicated surd transforms into a clean, exact answer. This is the power of rationalization and algebraic structure. When you see the pattern, everything falls into place.